So today, finally, Murata came to start OSI model. First of all, what is OSI? Okay, before this, today we'll be learning what is OSI. And before learning what is OSI, why OSI? Why OSI? What's the need of this? Next, what are the 7 layers of OSI? And why only 7 layers? Okay, and after learning 7 layers, just a roadmap of all these 7 layers, what each layer does. Just a basic roadmap, okay, not in depth. What each layer does. And understanding it with a real life example. First of all, why OSI model? Okay, what is OSI? Open System Interconnection. So the name itself, opening the system, interconnecting each and every other layer, okay? And it was developed by ISO. It's International Organization of Standardization. By seeing the abbreviation, right, you can think it's iOS, it's not ISO. But I don't know why they say ISO. I don't know why they say ISO, but they have named it as ISO, and the full form is like this: International Organization of Standardization. I was like, okay, their wish, I don't care. I just care about functions. I don't care about names. Okay. International Organization of Standardization. This word is very important. Standardization. These people developed OSI model to standardize, not size, standardize, oh man, standardize how communication works between devices, not us. Why only OSI? Why only OSI? First point, suppose before OSI model arrived, there were 2 major companies which were working on networking. Okay, one is IBM, the other one is HP. Not Hindustan Petroleum. It's not Hindustan Petroleum. Okay. Before, what was happening? These 2 companies decided to collaborate with each other. Example, not really. Example, okay. These 2 are enemies, bro. Okay, so now there is a network in IBM, LAN. There is a network in HP. Before the arriving of simple management transfer simple mail transfer protocol, SMTP. Okay, these IBM people want to send mail to HP people. Now these guys use latest protocol of mail, SMTP. They wrote an email, they sent. Now HP guys use X404. I don't know the exact number, but yes, it is X404 as far as I think. This is the oldest form of email protocol. So whatever format these people use, X404 has no idea about the format. Now IBM guys, as they want to collaborate with HP, they don't go directly. They send via email, bro, let's collaborate. Now it came here, that email got crashed. The email didn't even come here. Why? Because the X404 has no idea about the SMTP format of the email. Okay, that is the reason the email gone. That is the reason ISO developed OSI model. First of all, to ensure interoperability between networks or devices. Interoperability, so that everyone should follow same protocol. Bro, ensure that you are following. the same protocol, okay, before communicating to ensure interoperability between devices. First point. Second point, I told you, OSI model for standardizing how communication occurs. Standardizing how communication occurs. And the third major point, debugging. Don't write that. You can write because it divides the network communication into 7 layers, one by one. Because it divides communication into 7 layers. 7 layers seems huge, but these are nothing, very simple. Okay, you can also write debugging here. Debugging, why? See, example, there is a network here and the A device wants to send data to C device, A, B, C, D, okay? Now, you see, they are connected in ring network. Example, they are connected in the ring network. Now, you are able to see that the packet is going out of A. I mean, packet or frame. Let's consider frame, not packet, because this is a local network, right? A sends out the frame. But it is not reaching C. Somehow it is not reaching C. Now, what happens if you don't know OSI model? You'll break your head. What happened? You will go and check in your wire. Huh? Will you go into the wire and check where is the packet? You can't do that. Right? So, now, first of all, you know that the frame has gone out of A. Now, there can be only 2 issues. One is wire got cut. How you determine that? Using physical layer. Either wire got cut. Now you confirm that the wire is not cut. Okay. Second thing, what you will confirm is, bro, has the A device, NIC of A, put the correct source MAC and destination MAC? Right? Now this is data link layer. Right? If you don't know data link layer, how will you get to know that whether it has put the correct MAC or what? Yeah. You will inspect into NIC and you will see the destination MAC. Okay. If you should check whether it has put the correct MAC or not. Right? Am I correct? Only if you know the data link layer, you will get this thought. If you don't know data link layer, how will you get this thought? You will be like, hey, wire cut ho gaya. Wire is not even cut. Okay. And if you are able to see that the destination MAC is not coming, okay, you know it is a network layer problem. How? The ARP is not working. Address resolution protocol is a protocol which converts IP into MAC. Now you say it is not able to find the IP of C. That is the way you debug, right? And if you don't know these things, bro, example, you know the domain of C. C's domain is cip.com. Example, cdevice.com domain. Now how will you find the IP of C? Using DNS protocol. But how? Using some command line. You have some command line called as dig. When you do a dig in your system, right, you will get, okay, if you want to get accept this, you can go to C device. The C device is a computer, okay. You go to C, you do IP config. You put this command in the command line interface of device C. You will get the IP straight away. And using that IP, you can convert it to MAC. And then you can check if the MAC is correct or not, whatever A is putting. Simple. Now, I gave you an example that IBM guys are trying to reach out to HP. Okay. Now let's assume both are operating on the same protocol, same email protocol. Now let's see how they are reaching out to HP guys. Okay. IBM. And before this, OSI model is divided into 7 layers. Let's start from top. Application, presentation, third one, session layer, and then comes the major purpose TCP, not TCP, transport layer. It is a protocol which resides in transport layer. Okay, transport layer. Then comes network layer. Then comes MAC, data link layer. Then comes bits, physical layer. Okay. Now, IBM have an email application open on their PC. Now, the application layer of IBM, I mean the application layer of IBM's computer device, they create the data. You have written an email, you are clicking on send button. The first step is that application created the data. Okay. Now, the next layer, presentation layer. These guys add something called as PH, presentation headers. These are nothing but what kind of formatting is being used by this application layer protocol. I mean this device, I mean this application. Okay. Now, it is an email. It is using SMTP format. Now let's not write this. Let's not write this here. Example. It's using SMTP formatting. It will add a presentation header because when it reaches to end device, it will see, oh, it is using SMTP header. Oh, nice. We are not using SMTP. Gone. Let's assume we are using right now. Okay. Because for understanding, right? Okay. Now they add presentation headers. Listen, it adds formatting headers and also encryption headers. What is encryption? It is used for security, encrypting the data transferred in the email into some hash so that attacker cannot attack the data and get that out. Okay. Presentation layer adds PH header, nothing but encryption headers. After presentation, now comes session layer. Here the data also comes. Here the PH also comes. Now this guys adds session layer header. Session layer header are nothing but the header which your browser adds while communicating to the server. Okay. Example, get slash index.html. You have opened some network tab sometime? Have you opened a network tab sometime when your browser is sending the request? You see something like this, right? Get colon slash index.html. User agent Chrome. User agent is Chrome. These kind of headers, right? These layers are added by session layer. So session headers. But in real life, this model rarely exists because browser is an application. So browser itself adds these headers. So nothing but indirectly. Why in TCP/IP model the session layer, presentation layer, application layer are all combined into application layer? This is the reason, because the browser handles everything. When you make a request here, browser communicates with the server saying, hi, I am Chrome, I am running on this application. Okay, I support this type of encryption algorithm. Tell me what you support. He responds saying, let's do RSA. Then this guy will send RSA. Okay, before saying that, he will also send the public key of that RSA. Okay, he'll also send public key. So he will use this public key to encrypt all those, and that private key can decrypt. Maybe you don't know about RSA. Don't worry, I'll teach you later. Okay, public key, private key. So that's how. So that's the reason. See what presentation layer does. Formatting, encryption. These both are done by browser, right? What session layer does? Adding this header and establishing a connection. Browser does this. Okay. What is the duty of application? Creating the data. Browser is a place where you actually create the data. Either browser or application. So nothing but that is the reason why these three are combined into one in TCP/IP model. I told you almost entire world uses TCP/IP, right? This is just to make you clearly understand. This is a conceptual model, but TCP/IP is a practical model. There's a difference between conception and practicality. Okay? Session layer over. Now comes transport layer. It has data, it has PH, it has SH. Now it adds transport headers. What transport headers? But actually, who is the one who actually sends port? Transport layer. It will send the source port, it will send the destination port, it will also add sequence numbers. Suppose the IBM's message is, email message is very long. Bro, requesting, bro, please collaborate with me. Okay, it's very long message. Now it's so large that it cannot fit into one segment. It cannot fit into one segment. One segment has something called as MSU, maximum segment unit. MSU is nothing but the amount of bytes or the size which is supported by one segment. Okay, bro, understood, right? In this much, exact value I forgot. I'll check and tell, or else you can check. It is approximately around some 1000 bytes, I guess. Maybe. No, 1000 bytes. But emails, you know, emails will be in KBs. 6 KB, 7 KB, 6 MBs also. So they'll be divided into multiple segments, right? Some amount of data. Suppose hi HP, looking forward to collaborate with you, one segment. So we have come up with a plan of collaborating another segment, like that. Because see, if you see, it looks just simple. Hi, no, it's not that simple. When you divide hi into bits, right, it will be it will be very wrong. Okay. So that's the reason it adds a sequence number. Suppose hi IBM, one sequence number. Hi HP, one sequence number, and next comes looking forward to collaborate with you, second sequence number. So that when they are sent into the air, right, when they arrive at the receiver will take it in the form of correct sequence number. That will be handled by TCP itself. भाई वो जमा करके सब एक ही बार में भेजता है. It will wait till all the packets are arrived. Okay, all the segments are arrived. Okay. So these are nothing but transport. Hey, we have still more, bro. Acknowledgement numbers. Those all we will learn in TCP protocol. Okay. For now, just think these basics. Okay. Then comes network layer. क्या हो गया भाई? We have data here, we have PH here, we have session header here, we have TH here, and you know this network headers. What are those? Source IP, destination IP, time to leave. Time to leave is nothing but TTL. Like suppose if an IP is not reachable for a certain amount of period of time, just time out. Just time out. Leave it. Don't establish connection. Okay. Network layer over. These are simple letters. I'll explain. There are a few more. Let's catch up later. Network layer over. Then comes data link layer. We have data here. We have PH here. We have SH here. We have TH here. We have network layer here. Data link layer headers. What are those? Source MAC, destination MAC. Checksum, I told you, error checking. Data link layer also does error checking. CRC bits, CRC header. Not CRC header, it's trailer. So in header we have source and destination MAC. In trailer of the frame, we have CRC. Nothing but cyclic redundancy check. This is nothing but a very popular error checking mechanism in the bits. Okay? When we start the data link layer, you will learn about this. This is very important. Even in your college exams, you will get. Okay. Then comes physical layer. We have data here. We have physical here. We have SH here. We have TH here. We have NH here. We have DH here. Now, what will come here? Does physical layer add some headers? No. Now this layer sends out the data. Sends out the data as signals or bits. Now when it comes to HP, it will go swing, 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 swing. Got it? This is what a brief overview of OSI model. Brief overview.